So today we're starting trigonometry. So second semester is trigonometry. We have less topics than first semester, so it goes a little slower, but sometimes you need a little more time to kind of invest in that material. You will have some sections that calculators are not allowed. There are things you're going to have memorized that you're just not allowed to use a calculator. I'll let you know when that happens. Some of this stuff you have to have a calculator. I'll let you know, those particular things that you have to have memorized and so on. We're going to start out with the trigonometry that you learn in usually Algebra 1, Geometry, Algebra 2. So sine, cosine, tangent. And then we're going to build upon it until we can move outside of a triangle. We're going to do something called a unit circle that some Algebra 2 teachers get a chance to kind of touch upon. But I'll assume you've never seen it before. In this course, there's going to be a lot of things that you're going to want to memorize. They're going to need to memorize. So we will have some memorization quizzes along the way to make sure you have those items memorized. Now we're going to start out, like I said, in the regular right triangle trig that you're familiar with. So we're going to find the values of the trig functions for acute angles. So we're talking about stuff that is nested inside of a right triangle, okay? And then to solve a right triangle means, hey, let's solve every single piece, every side and every angle. That's what that means there, and we'll talk about how to do that. So first off, the trig functions that you need, let's start out, go down your page on the left side. So the ones that people are most familiar with are the sine, the cosine, and the tangent. The abbreviation for the sine is SIN. Do not say sin. That is not what it is. It is an abbreviation for sine. Just like Mrs., MRS, is the abbreviation for Mrs. You don't say MERS when you see that. Sine is SIN. Cosine is COS. Tangent is TAN. Don't say sin, cos, and tan. It drives me nuts because that's not what it is. Please call it sine, cosine, and tangent. Now, let's take a look at this triangle before we fill this stuff in, or you might have already started writing. That's fine. If you have an angle in a right triangle, these are the acute angles, and it doesn't matter which. If you are across for it, you're labeled opposite, OPP. If you are the leg that is next to it, you are labeled adjacent. And if you are the longest side across from the right angle, you are the hypotenuse. You have to know how those are situated. For this angle, this is the opposite, this is the adjacent, and this is the hypotenuse. If you're up in this corner, this is the opposite. This is the adjacent, but this is still the hypotenuse. So the opposite and adjacent flip around locations depending upon where your theta is located. Now it's important to know that Greek letters are used often when we are dealing with right triangle trigonometry. An angle measure is usually going to be given as a Greek letter, but it's just a variable that stands for an angle measure. So that is the variable theta. So get used to making almost a zero with a slash through the middle. Don't make it that way. Slash up and down denotes something different. That's a null set for set notation, okay? So get used to, I'll introduce you to some Greek letters if you haven't used those before. Now, sine is the relationship how an angle is opposite over hypotenuse. So in our angle here, or in our triangle here, it would be the relationship of the opposite and the hypotenuse. Because the hypotenuse is the longest side, that is always a proper fraction. If you were to put it in a calculator, always is 0 point something, or maybe exactly 1. Eventually. The cosine is adjacent over hypotenuse. So it's the relationship for that adjacent and the hypotenuse. In a right triangle, it will always be a proper fraction. And then finally, the tangent is the opposite over adjacent. Now, most people learn that earlier in, so you probably already learned that. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You want to kind of think about it in that order. A silly way that some math teachers teach, and it's a great way to memorize it, is SOH-CAH-TOA. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. SOH-CAH-TOA. It's this very silly but very effective way to have those memorized. You have to have those memorized. Those eventually will be on a memorization quiz. Now, the ones that people don't necessarily remember or maybe aren't introduced to until right now are these three. These three are considered the reciprocals of what you see to the left. The cosecant is the reciprocal of the sine. That's why I write it like that. I write it next to it. The cosecant and the sine are reciprocals. So the cosecant is hypotenuse over opposite. It is abbreviated CSC. So when you see CSC, think cosecant. Cosine and secant are reciprocals. Secant is hypotenuse over adjacent. And tangent and cotangent are reciprocals. They are adjacent over opposite. Disregard the cos. The cos don't go together as far as reciprocals go, except tangent and cotangent. They are named for what their graph looks like. They are named for what their graphs look like. These two are co-functions. Their graphs look alike. These two are co-functions. Their graph looks alike. These two are co-functions. Their graph looks alike. So the co-function, the word co does not indicate that they are reciprocals. No. It's just kind of a coincidence. So sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. I always write them in that order. I make a column and do sine, cosine, tangent. I make a second column and I always write cosecant, secant, and cotangent. Always write them in that order and you're less likely to forget. I will write them in that order as I go through the process so that you can try to memorize how they all go together, okay? But you have to have those memorized. Any questions about what we see there? Okay. So let's look at the example we see here. Find the exact values of the 6 trig functions. Now, on your page, you only have 2, but I forget which ones you have. Oh, you're missing the 3rd. Okay. So, yes, you can put the 33 there, but what I want you to do is I want you to think about how would you find the 3rd side? Well, in geometry class, maybe even in Algebra 1, you were taught the Pythagorean theorem. A squared plus b squared equals c squared. The A and B must be either of the legs, the thing that form the right angle. Those are the legs. The C must be the hypotenuse. So if you were to figure out the missing side of 33, you would have to go that 65 squared. No, I'm sorry. 56 squared plus b squared equals 65 squared. 56 squared is 3136. 65 squared is 1089, or is a big number. When you subtract those, you get 1089. So the square root of that is indeed 33. So the 33 comes about using the Pythagorean theorem. So if you are missing any one side of a right triangle, you must find the missing side before we proceed using the Pythagorean theorem. The A and the B are the legs. The C is the hypotenuse. The C is always the biggest value. Okay, so that's what we have to do before we proceed. Make sure that you do that. Okay. The next thing you want to do before you go and jump into the actual 6 trigonometric functions is you want to label what those sides are in relationship to where your angle is. So here's our angle. The one directly across from it, please label that as the opposite. So I always put OPP like they saw earlier. The one that's attached to it but a leg is always the adjacent. And the one that's across from the 90 degree, the largest value is always our hypotenuse. So again, before we do this, there are 3 things that you must always do. Well, 4, it depends on how you think about it, but do I know all 3 sides? If you don't, fix it. Then label what all sides are. So you do that before you proceed, okay? Once you have all 3 sides values, you have all 3 sides labeled, now you proceed to do the next thing, okay? So you're going to write sine of theta, cosine of theta, tangent of theta. Now, using what we learned earlier, using our SOH-CAH-TOA, the sine is opposite over hypotenuse. Just go in order. So sine is opposite over hypotenuse. Cosine is the CAH, that's adjacent over hypotenuse. And then tangent is opposite over adjacent. So all I want you to do now, see how it used the instructions to find the exact values. Don't throw this into a calculator. I am going to mark it wrong. Exact values mean I want the fractional value. Then stop. As long as your fraction is reduced, stop. I want a fraction. So the first one here, our sine value, the opposite was 33. The hypotenuse was 65. If you try to reduce 33 over 65, you cannot. So that's what I want. That's your answer. The ratio of the opposite side and the hypotenuse side when the angle theta is the theta that's marked is 33 over 65. That's it. That's your answer. Now let's do cosine. Cosine is adjacent over hypotenuse, so that's 56 over 65. 56 over 65 can't reduce either. Just leave it alone. And then finally, opposite over adjacent is 33 over 56, which also cannot reduce. Leave it. That's your answer. Now that you've done those 3, and always make them a column, for a while, always follow the same pattern. Your life will be easier. We're going to now write the 3 reciprocals, always in the same order. The reciprocal of a sine is a cosecant. The reciprocal of cosine is secant. One way to remember, I know sine and cosine go to an S and a C go together, and an S and a C go together. I don't know if that'll help you, but the reciprocal of a tangent is a cotangent. Now, you don't have to write the fact that it's cosecant is hypotenuse over opposite, and secant is hypotenuse over adjacent. You can write them if you want, but all we have to know is what they're the reciprocal of. Cosecant is the reciprocal of the sine, so instead of doing opposite over hypotenuse, we're going to do hypotenuse over opposite. We have the fraction sitting right there. 33 over 65 becomes 65 over 33. That's the exact answer. You're done. Bam. Secant is the reciprocal of the cosine, so it's hypotenuse over adjacent, so it's 65 over 56. Cotangent is reciprocal of tangent, so it's adjacent over opposite, or 56 over 33. Bam! We have found the exact values of the 6 trig functions in this relationship of theta. So let me remind you of the rules one more time, or what you want to proceed with. If you're missing a side, find the missing side using the Pythagorean theorem. Label your sides. First do sine, cosine, tangent, SOH-CAH-TOA. Then do the 3 reciprocals. The reciprocal of a sine is a cosecant. The reciprocal of a cosine is secant. The reciprocal of a tangent is cotangent. Make sense? Okay, let's proceed. Let's do another one. So initially, you are missing a side. You are missing this side. So how do we know it's 20? Well, the two that make your right angle are the legs. They're the smaller side. We are missing our hypotenuse. So I know that 12 squared plus 16 squared has to equal c squared. 12 squared plus 16 squared equals c squared. We've got to find that 20. So you got to know how to find that 20 if it wasn't written on the page like mine is. Well, 12 squared is 144. 16 squared is 256. You add them together, you get 400. So C is the square root of 400, or 20. Now, you don't have to put the plus or minus here. There's going to come a time once we move outside of a triangle that the plus or minus becomes an issue we have to deal with. But these are lengths of sides, so we don't need to deal with that right at this moment. Once you have all of the sides on your triangle, now we go and label what they are. So let's go to our triangle for a moment. Make sure you put your hypotenuse as 20. And we know that's the hypotenuse. We've already kind of analyzed that part, so you can write that as hypotenuse. Where the angle is sitting, this side, I always find the opposite first. It just helps my brain. So I do the opposite. It's very visible. I am opposite my theta. And so that means this one is my adjacent. So again, you find all three sides. Once you know all three sides, label them. Now we're ready to proceed with our SOH-CAH-TOA. Okay. I again tend to always write them in the same order. Sine of theta, cosine of theta, tangent of theta. So then you'll have them memorized. Be consistent, please. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is TOA. That's opposite over adjacent. So SOH-CAH-TOA gives us that very nicely and easily. Okay. So let's proceed with the first three, our first column. Sine is opposite over hypotenuse. Our opposite is 12, our hypotenuse is 20. Now I do want that in reduced form, but I do want fractional form. Both 12 and 20 are divisible by 4. Let's divide it. So we get 3 over 5. Let's take a look at our cosine. Oh, cosine is adjacent over hypotenuse, so 16 over 20, which is 4 over 5. And our tangent is opposite over adjacent, 12 over 16, or 3 over 4. Because sine, its numerator is opposite, and cosine's numerator is adjacent, tangent should be these two things, 3 over 4. 3 over 4 is kind of another check that you can make. Okay. Now that we've done those, you always do that column first because that's going to give us the answers to the next column. Please write it always in the same order, cosecant, secant, and cotangent. You can write what they are. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. But just think, I know what their reciprocal is. I'm going to flip it over. But if you flip over 12 over 20, you get 20 over 12. What does it reduce down to? 5 over 3. So you've already done that work of reducing. My suggestion, you don't have to, but it sure makes it nicer to flip over the one that's already reduced for you. So 3 over 5, just flip it over and make it 5 over 3. 4 over 5 becomes 5 over 4. And 3 over 4 becomes 4 over 3. Again, you could have done 12 over 16 becomes 16 over 12, but what does it reduce down to? 4 over 3. So why not reduce that? Use the one that is most convenient to flip over that gives you the less work to do. Be mindful that I can pick which one I want to flip over. The reciprocal of 12 over 16 is the same as the reciprocal of 3 over 4. So why not do 3 over 4? Make sense? Everybody good with this example? Okay. Let's take a look at this one. Now, before you really kind of look at mine, okay, I want to talk about, there's probably not even a triangle on your page. Is that true? There's a triangle, but it's completely blank? Okay. So the first thing I want to talk about is how did I set up this triangle? Okay. So think about that the sine is 1/3 tells us we can set up a triangle where the opposite is 1 and the hypotenuse is 3. So the first thing you want to do is make your theta in the bottom corner. You could really put it in the top corner too. It doesn't matter. Just pick a corner, put it in. Please make the opposite as 1 and your hypotenuse as 3. So that's the first step you want to take. You want to physically make a triangle where the opposite is 1 and the hypotenuse is 3. So then that allows us to find the missing side. So that would be a missing leg. So if we do a squared plus b squared equals c squared, because you have to have all 3 sides before we move on, that would be 1 squared plus b squared equals 3 squared. 3 squared is 9, 1 squared is 1, 9 minus 1 is 8, so b squared is 8. So b is the square root of 8, which since 8 is 4 times 2 is 2 radical 2. Put 2 radical 2 in your triangle as your missing side. Okay. So now that we have, let's think about what we did. We drew our triangle that fit our situation. The sine was 1, that's opposite over hypotenuse. I put an opposite of 1, a hypotenuse of 3. I used Pythagorean theorem to find my third side. Once you have all sides labeled and you know their numerical value, now you proceed. Even though it says to find the exact values of the 5 remaining, I still write what I know. The sine of theta, I still put them in the exact order. It's like they gave me a bonus. They already told me that the sine was 1/3. Yay. They've told me that. Okay. So what's the cosine? Well, the cosine is adjacent over hypotenuse. If we think about our SOH-CAH-TOA, CAH is adjacent over hypotenuse. The adjacent is 2 radical 2, and the hypotenuse is 3. And what's our tangent? Tangent is opposite over adjacent, which is 1 over 2 radical 2. Now, I want exact values. That's the exact value. But I want it in the form that is acceptable mathematically. Mathematically, we should never have a negative in our denominator. We should have a decimal in our denominator. We should never have a radical in our denominator. So we have to rationalize. But rationalizing a square root is very super easy. Let me remind you how to do it. Just multiply top and bottom by that matching radical. It will pop the radical to the top and leave a normal number behind. Now, it leaves the 2 and another 2, because radical 2 times radical 2 is 2. So it leaves actually 2 times 2, or 4, behind. Okay. So now we have the original 3 we always learn. That's SOH-CAH-TOA, that's sine, cosine, tangent. On the right column, make a right column, please, for me now, with the 3 reciprocals. The 3 reciprocals are cosecant, secant, cotangent. So our sine, 1 over 3, becomes 3 over 1. Now, if you write 3 over 1 and then 3, that's fine. If you, in your head, can jump right to 3, that's fine too. Okay. Secant would be 3 on the top, 2 radical 2 on the bottom. We got to fix that. We can't have radicals in our denominator. Just multiply top and bottom by radical 2. We get 3 radical 2 over 4. But let's talk about the cotangent. You can flip over any version. You can flip over this one. You can flip over this one. If we flip over the very first one we set up, it naturally just puts the radical right in the top. So why not? So it would be 2 radical 2 over 1, or 2 radical 2. So I always flip the one that I can be the laziest. so that I don't have to work harder, work smarter. So pick the one that is the most convenient to flip. So that one flipped my radical to the top, so I didn't have to rationalize. If you rationalize this, you have a few steps before you get to that, because you have to multiply by radical 2 on top and bottom. You get a 2, and then the 2's cancel. You know, it's a lot more work. So flip the one that's most convenient. Okay. Any questions about example 2? Okay. Now you might wonder why there were 2 examples labeled example 1 and 1 example labeled example 2. We're actually on the 4th thing we've done, but it says example 3. Okay. I want to talk about that for just a minute. In the homework, again, I doubt we're going to get through these notes today, but that's okay. See how right here it says example 1 in that little orange font, that little orange print? And right here it says example 2. And then right here, I don't know if you can see it, but it says example 3 and so on. This means that that one looks like all the ones that are labeled example 1. So it's just pointing you back to what to look at in the notes. So it's very nice in that it kind of lines up perfectly and it tells you what to look at. If you're stuck on what do I do? Hey, I can look at anything that's labeled example 1 for these ones, anything that's labeled example 2 for those ones, and so on. Okay, just so you know, since these are kind of a new type of note sheet. Okay, so now let's look at another one labeled example 3. It says, find the value of x rounded to the nearest tenth. Now, in the problems we've done so far, you have had 2 out of 3 missing sides, so you could use Pythagorean theorem. So Pythagorean theorem is always a route we want to take for a right triangle. If we can take it, do it. Okay. But when we can't do it, that's where trigonometry came from in the first place. Okay. Now we're still going to somewhat proceed how we've done the last problems. Now let me show you what I mean. Where our angle is sitting, I want you to label the sides that are marked. Okay. So this is our hypotenuse. We know it's across from the 90. It's our largest side connecting those legs. This is not opposite the angle. It's adjacent to the angle. So please mark that as our adjacent. So we're going to label the things that they marked. Okay. And then we're going to think about our SOH-CAH-TOA for a minute. And we're going to think about which one includes adjacent and hypotenuse. Which one of the SOH-CAH-TOA, the sine, the cosine, tangent, includes adjacent and hypotenuse? Cosine. The cosine is the CAH, the adjacent and hypotenuse. So once you figure out which one to use, could you please write it down? The cosine of theta is adjacent over hypotenuse. Let's think about it as an equation that we are going to plot the information into, and we're going to substitute in so that we can solve the equation. Okay, so theta, remember, this is theta, is 35. Let's put that in. The adjacent, they said, was x. The hypotenuse, they said, was 7. Okay. Do you see these words right here? Round to the nearest tenth. The ones we have done before this have all said use exact values. That round to the nearest tells me we have to use a calculator. You have to make sure your calculator is in degree mode. So if you look at this big calculator that's beside my projector board here, if you look here, at the very top of the calculator, including the red ones on the back table, next to the second button, there's a button that says DRG. That means degrees, radians, and gradians. Now, gradians is used more in an engineering application. They're usually not used in math class. They're very similar to a radian. But in our class, we need to know how to flip our calculators from degree and radian and gradient, but mostly degrees and radians. See how on the calculator that's up on that my big poster, see it, if you can see it from where you are, you have young eyes, most of you probably can. There's a little RAD. This calculator is in radian mode. So if you picked a red calculator off the back table and it had a little RAD in the corner, you're going to get the wrong answer. So all you do to switch it is you hit the DRG button. Screen will appear. Make sure degrees is underlined. Okay. So that being said, we need to know what the cosine of 35 is. See how it says round to the nearest tenth? So when we put this into a calculator, I'm going to take it out about 3 decimal places, sometimes even 4, so that when I get my final answer, it'll round nicely and get me the answer I want, okay? So all I got to do first, let's put that into a calculator. The cosine of 35, if your calculator is in degree mode, because a degree and a radian are very different things, you'll learn eventually, you're going to get 0.8192. So I rounded to 4 places. Okay. Now let's think about how we solve that. Now that nothing's in there but numbers, hopefully you recognize that if I multiply by the denominator of 7, I'm going to find x. So I'm going to multiply both pieces by 7. If I multiply the 0.8192 to 7 and round to the nearest tenth as they've indicated, the answer is 5.7. Now, once I know that that is 5.7, since I have 2 sides, if I needed this side, I could use Pythagorean theorem now. But before that, I couldn't. And that's where trigonometry allows us to find the ratio of an angle and 2 sides. We don't need a third side. And that's what's helpful about trigonometry, is that it relates angles and sides even if we don't have all 3 sides. And then eventually, not even if it's in a right triangle, we'll be able to find angle measures and cosines and sines of lots of things. Okay? Everybody good with example 3? Okay. Let's do the next example 3. It says find the value of x and round to the nearest tenth if necessary. Find the value of x and round to the nearest tenth if necessary. So we have this angle measured of 41 degrees. We are going to label what we know in the relationship of where this angle is located. This is the opposite. This is the hypotenuse. This is our theta. Okay. So again, you'll notice in almost every single problem, labeling the sides was very essential. Please make sure you're doing that. So if we look at our SOH-CAH-TOA this time, which one of our trig functions, sine, cosine, or tangent, uses opposite and hypotenuse? Which one uses opposite and hypotenuse? SOH, CAH, or TOA? Sine, cosine, or tangent? Which one? Yes. The sine does, right? So now let's write down the formula so that we can use substitution and plop the stuff in. So the sine of theta is opposite over hypotenuse. That's the formula we're going to use. Let's plop the junk in. So the sine of 41 degrees is opposite 7 over hypotenuse x. Now let's get a number for the sine of 41, just like I did for the last problem. I'm going to take it out at least 4 decimal places, or just leave the decimal that pops up in the calculator. I get 0.6561 equals 7 over x. Now in the last example, we multiplied by the denominator of 7. No matter what the denominator is, even if it's an x, you first have to multiply both sides by that denominator. So that's why I like they gave you one that had the 7 in the denominator, and then they gave you one that had an x in the denominator. I like that because it reminds you, no matter what, cross multiply. This is, you love cross multiplying. Here's an opportunity to do that. So we get 0.6561x equals 7. Now it's just an algebraic equation, a simple one at that, a one-step algebraic equation. How do you solve for x? We've got to divide. Got to take that 0.6561 and divide it off. So we're going to divide both sides by 6561. Should our answer be less than 7 or more than 7? Looking back at our triangle, should our answer be less than 7 or more than 7? More than, it's a hypotenuse. If you divide by a 0 point something, you always actually end up getting larger. Think about if I divide by half, I'm really doubling it. Okay, so it's going to be larger than 7. That's a great sign that we did it right. So put your number in context. Your hypotenuse should always be your largest value. If it isn't, you did it wrong. Okay, so if we get our final answer now, 7 divided by 0.6561 rounded to the nearest tenth, let's follow those final instructions. We get 10.7. Should we expect that our hypotenuse is bigger than 7? Yes. Was it bigger than 7? Yes. So that's a really good, just quick little check. If we wanted to find the other missing leg now, we can use Pythagorean theorem. Before that, we couldn't. We had to use a trig function. And again, that's the beauty of our trig functions. Do we have any questions about that example 3? Okay. So we are going to stop here. You're going to hold on to these notes. Tomorrow we're going to finish the notes and you'll have a little bit of time in class to work on the homework, but it's a good idea to maybe start it now. So let's look at what we've done. If you look at the homework, which is on the last page, we have done some problems labeled example 1. So you can definitely do those first 4 problems. We've done some problems labeled example 2. We've done some problems labeled example 3. So you're ready to do those 3 problems right here, those 3 sets, okay? So it's a good idea. You have a few minutes right now to try maybe one of each of those, okay? So please work on those ones. And then tomorrow, we're going to do some problems labeled example 4, 5, 6, and 8, okay? So there you go. Go to town, do a little bit of math.